HOWTO Part 2 Performing Matches. Once you have an object representing a compiled regular expression, what do you do with it? What do you do with it? Pattern objects have several methods and attributes. Only the most significant ones will be covered here. Consult the RE docs for a complete listing. Method attribute purpose match, search, find all, find iterator. Match determine if the RE matches at the beginning of the string. Search scan through a string looking for any location where this RE matches. Find all substrings where the RE matches and returns them as a list. Find iterator find all substrings where the RE matches and returns them as an iterator. Match and search return none if no match can be found. If they are successful, a match object instance is returned containing information about the match, where it starts and ends, and the substring is matched, and more. You can learn about this by interactively experimenting with the RE module. This how-to uses the standard Python interpreter for its examples. First, run the Python interpreter, import the module RE, and compile a RE. Let's do this example. So compiling, importing is already done. Let's do this. So here in ID I need to use print method to print the match object value. So here re.compile is the string regular expression, and this is the content of re.compile. And now you can try matching various strings against the RE A to Z plus, and empty string shouldn't match at all. Since plus means one or more repetitions, match should return none in this case, which will cause the interpreter to print no output. You can explicitly print the result of match to make this clear. So p.match this one and print. Now p.match this one and then print p.match this. None, correct? Now let's try it on a string that it should match, such as tempo. In this case, match will return a match object, so you should store the result in a variable for later use. M is equal to page tempo, it will match M. Print M. Run. It will match object span match found at 0 to find 5. 0 1 2 3 4. 5 is exclusive. Match is equal to tempo, right? And if we try to print its start, so this is a start. Let's print start, and then let's do it this way. This will be start dot format m dot start, and then let's print start is equal to this, and is equal to this, comma m dot and match is equal to this, m dot n, no, m dot match. I pass tempo and it will print only tempo, right? So now you can query the match object for information like span. Even let's try with span. So span is equal to span, and here let me put m dot span. Span is 0 to 5, and group. Right. Trying these methods will soon clarify the meaning. M dot group tempo, M dot start, M dot end 05, M dot span. This group returns the substring that was matched by the RE. Start and end return the starting and ending index of the match. Span returns both start and end indexes in a single tuple. Since the match method only checks if the RE matches at the start of a string, start will always be 0. However, the search method of patterns scans through the string, so the match may not start at 0 in that case. For example, p dot match, print p dot match this. Let's run it, none, and p dot search this will print, will find it. So print m will match re object 4 to 11, 0 1 2 3 4 to 11, 5 6 7 8 9 10, 11 is excluded. M dot group, if I try to print m dot group, it will print message, right? And m dot span will print 4 to 11 as a tuple, including both start and end. And in actual programs, the most common style is to store the match object in a variable and then check if it was none. This usually looks like this. Okay. re dot compile dot dot dot, re dot compile dot dot dot. String goes here, print match found. Okay. For example, re dot compile regular expression. Let's use w plus, right? W plus, string goes here, match found, string. Like this. Two pattern methods return all of the matches for a string. Find all returns a list of matching strings. So p compile this, find all. So this will find all the matches, where matches of digits in the string. If I print p, it will print 12. Okay. P dot group. Okay. This will be a list of matches. M and print M. This will return match. So 12, 11, 10. The R prefix, making the literal a row string literal, is needed in this example because escape sequences in a normal cooked string literal that are not recognized by Python, as opposed to regular expressions, now result in a deprecation warning and will eventually become syntax error, see \flag. Find all has to create the entire list before it can be returned as the result. The find iterator method returns a sequence of match object instances as an iterator. For example, p dot find iterator. Let's do d iterator and then print iterator. It will print iterator object, callable object iterator, and for matches in iterator, print m dot print m print m dot group. 12, 11, 10. And if I say and is equal to space, and here print open, and is equal to comma, open, and is equal to blank, print backslash, run it, comma I don't need, so result is equal to this, result is equal to this, and here I will say result is equal to result plus m dot group m dot group plus comma, and here result is equal to result dot substitute result dot replace comma and to bracket and print result. Run it. Okay. Why? Okay, it will print like this, correct? Module level functions. Module level functions. You don't have to create a pattern object and call its methods. The RE module also provides top level functions called match, search, find all, sub, and so forth. These functions take the same arguments as the corresponding pattern method with the RE string added as the first argument and still return either none or match object instance. Print re.match print re dot match r from s plus from h. Yes, it will print none. Why? From backslash s plus. Why none? Because of this. Hmm. It will match. And what was here? Why? From s none and this. Okay, exact match. That's fine. This will match. Correct. But this won't. Okay. And print, we show the example already. So under the hood, these functions simply create a pattern object for you and call the appropriate method on it. There is no need to run compile method. They are store the compile method. They also store the compiled object in the cache. So future calls uses the same re, won't need to parse the pattern again and again. And to release that page, you have to run re.purge method to clear regular expression cache. We have to explicitly call this. Should you use these module level functions, or should you use the pattern and call its methods yourself? If you are accessing a regular expression within a loop, pre-compiling it will save a few function calls outside of loops. There is not much difference thanks to the internal cache. Compilation flags. Compilation flags let you modify some aspects of how regular expressions work. Flags are available in RE module under two names, a long name such as ignore case and a short name. One letter from such as I. If you are familiar with Perl pattern modifiers, the one letter forms use the same letters. The short form of re.verbose is re.x. For example, multiple flags can be specified by bitwise ORing them. re.I or re.m sets both I and m flags. For example, here is a table of available flags followed by a more detailed explanation of each. Flag meaning ASCII, A. Make several escapes like \w, \b, \s, and \d match only on ASCII characters with the respective property. Dot all, s. Make dot match any character including new lines. Ignore case, I. Do case insensitive matches. Local, L. Do a local aware match. Multiline, m. Multiline matching affecting caret start of the pattern expression and dollar end of the expression. Verbose, x for extended. Enable verbose REs which can be organized more clearly and understandably. re.I, re.ignore case. Perform case insensitive matching. Character, class, and in literal strings will match letters by ignoring case. For example, capital A to Z will match lowercase letters too. Full Unicode matching also works unless the ASCII flag is used to disable Non-ASCII matches. When the Unicode patterns A to Z or A to Z are used in combination with ignore case flag, um, they will match the 52 ASCII letters and 4 additional non-ASCII letters I, U plus 0130 Latin capital I with dot above, I, U plus 0131 Latin small letter dot less I, F, U plus 017F Latin small letter long s, and K, U plus 212A Kelvin sign. Spam will match spam, spam or F palm. The latter is matched only in Unicode. This lowercase does not take the current local into account. It will if you also set the local flag. re.l re.local. Ignore case. For example, let's see the example of ignore case. Let's say W plus, okay, and then match comma. Ignore case. So here say from age, right? So it will print match found from age, although it is small. Because of this, if I remove this, it will not match, none. And if I provide it again, re dot ignore case, I can use the shorthand form like this, and it will match. re.local make backslash w backslash capital W backslash b backslash capital B a case sensitive and case insensitive matching dependent on the current local instead of the Unicode database. Locals are a feature of the C library instead to help in writing programs that take account of language differences. For example, if you are processing encoded French text, you would want to be able to write a backslash w plus to match words, but the backslash w only matches the character class A to Z capital A to Z small in bytes pattern. It won't match bytes corresponding to E or French letter C. If your system is configured properly and a French local is selected, certain C functions will tell the program that the byte corresponding to E should also be considered a letter. Setting the local flag when compiling a regular expression will cause the resulting compiled object to use these C functions for backslash w. This is slower but also enables backslash w plus to match French words as you would expect. The use of this flag is discouraged in Python 3 as the local mechanism is very unreliable. It only handles one culture at a time and it only works with 8-bit locals. Unicode matching is already enabled by default in Python 3 for Unicode str patterns, and it is able to handle different locals per language or languages. re.m, re.multiline, caret and dollar have not been explained yet. They will be introduced in section more meta characters. Usually caret matches only at the beginning of the string and dollar matches only at the end of the string and immediately before the new line, if any. At the end of the string, when this flag is specified, dollar matches at the beginning of the string and at the beginning of each line within the string, immediately following each new line. Similarly, the dollar meta character matches each either at the end of the string and at the end of each new line immediately preceding each new line. re.s re.all makes the dot special character match any character at all, including a new line. Without this flag, dot will match anything except a new line. re dot a re dot ASCII mac backslash w backslash capital W backslash b backslash capital B backslash s and backslash s to perform ASCII only matching instead of a full Unicode matching. This is only meaningful for Unicode patterns and is ignored for byte patterns. re.x re.verbose. This flag allows you to write regular expressions that are more readable by granting you more flexibility in how you can format them. When this flag has been specified, white space within the RE string is ignored, except when the white space is in character class or preceded by an unescaped backslash. This lets you organize and indent the RE more clearly. This flag also lets you put comments within a RE that will be ignored by the engine. Comments are marked by a hash that is neither in a character class or preceded by an unescaped backslash. For example, here is a RE that uses re.verbose. See how much easier it is to read. Char reference re.compile r. So this one re.verbose. Okay, char reference. Let's use it. Char reference. Char reference is re.compile r triple is triple quoted strings ampersand has start of a numeric entity reference, then character class, define a group 007 octal form or 09 plus decimal form or x 0 to 9 a to f a to f plus hexadecimal form, end of group, colon, trailing semicolon, re.verbose, print char ref. It will print like this, and without verbose setting, with verbose setting, re.verbose char ref. Without verbose setting, this will only print the regular expression. re.control. Okay, let's copy and paste. Without verbose setting. What is the difference, man? In the above example, Python's automatic concatenation of string literals has been used to break up the RE into smaller pieces, but it's still more difficult to understand than the version using re.verbose. This will look like this. More pattern power. So far we have only covered a part of the features of regular expressions. In this section we will cover some new meta characters and how to use groups to retrieve portions of the text that was matched. More meta characters. Uh, there are some meta characters that we have not covered yet. Most of them will be covered in this section. Some of the remaining meta characters to be discussed are zero width assertions. They don't cause the engine to advance through the string. Instead, they consume no characters at all and simply succeed or fail. For example, backslash b is an assertion that the current position is located at a word boundary. The position is not changed by the backslash b at all. This means that zero width assertions should never be repeated because if they match once at a given location, they can obviously be matched an infinite number of times. Pipe alternation or the or operator. If a and b are regular expressions, a or b will match any string that matches either a or b. Or pipe has very low precedence in order to make it work reasonably when you are altering multi-character strings. Crow or servo will match either crow or servo, not crow, w or s and servo. To match a literal pipe, use backslash pipe or enclose it inside a character class as in this. Caret matches at the beginning of lines. Unless the multi-line flag has been set, this will only match at the beginning of the string. In multi-line mode, this also matches immediately after each new line within the string. For example, if you wish to match a word from only at the beginning of a line, the RE to use at the red form, caret form. Print this. Print RE.search from, it will print match form. Print RE.match from setting it print none. To match a literal caret, use backslash caret. Dollar matches at the end of a line, which is defined as either the end of a string or any location followed by a new line character. Print search match the end of line. Like closing brace at the end of line. Match, this time it will match. And print. Okay, so if there is a space, it will not match. If there is not any space, it will match. Okay, a backslash a match only at the start of the string when not in multi-line mode. Backslash a and caret are effectively the same. In multi-line mode they are different. Backslash a still matches only at the beginning of the string, but caret may match at any location inside the string that follows a new line character. Backslash z matches only at the end of the string. Backslash b word boundary. This is a zero width assertion that matches only at the beginning or end of a word. A word is defined as a sequence of alphanumeric characters, so the end of a word is indicated by y space or a non-alphanumeric character. P dot this. P dot this. I dot in class. Now print search no class at all. B dot search no class at all. This will be a match. 3 to 8. 3 to 8. 0 1 2 3 4 5 6 7 8. Yes. And print discarded algorithm. The disclose match, yeah, 3 to 8 on. Why? Why? Hmm. Class is not present there, that's why. This class is not present, that's why. Subclass, this will also be none because no space is before class word. There are two subtleties you should remember when using this special sequence. First, this is the worst collision between Python's string literals and regular expression sequences. In Python's string literals, backslash b is the backspace character, ASCII value 8. If you are not using row strings, then Python will convert the backslash b to a backspace and your array won't match as you expect it to. The following example looks the same as our previous RE but omits the R in the front of array string. Now it will print none. If I remove this, so this will print none, none, none. And if I want to match it, so I have to escape this B, and this will now work again. So instead we should use this row string by prefixing it with R. Second, inside a character class where there is no use for this assertion, backslash b represents the backspace character for compatibility with Python's string literal. Backslash capital B, another zero width assertion. This is the opposite of backslash b, only matching when the current position is not a word bound. Grouping. Frequently, you need to obtain more information than just whether the RE matched or not. Regular expressions are often used to dissect strings by writing a RE divided into several subgroups which match different components of interest. For example, an RFC 822 header line is divided into a header name and header value separated by a colon like this. From colon author at the rate example.com, user agent colon thunderbird 1.5.0.9 in parenthesis x11 by 2006 1227, mime version colon 1.02 editor at the rate example.com. This can be handled by writing a regular expression which matches an entire header line and has one group which matches the header name and another group which matches the header value. Groups are marked by the open parentheses and close parentheses meta characters. Open and close parentheses have much the same meaning as they do in mathematical expressions. They group together the expressions contained inside them, and you can repeat the contents of group with a quantifier such as star plus question mark or m to n range. For example, AB star will match 0 or more repetitions of AB. Compile and print this. For example, compile AB star AB 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 dot span. It will print 0 1 2 3 4 5 6 7 8 9 10, 0 to 10. Groups indicated with open close parentheses also capture the search starting and ending index of the text that they match. This can be retrieved by passing an argument to group start and span. Groups are numbered starting from 0. Groups 0 always present. It is the whole RE. So match object methods all have group 0 as their default argument. Later we will see how to express groups that don't capture the span of the text that they match. Print m dot group 0. Print m dot group. Let's run it. AB both are same. Subgroups are numbered from left to right from one upward. Groups can be nested. So to determine the number, just count the opening parenthesis character going from left to right. P dot combined 0. Print m dot groups. Print m dot group 0. Print m dot group 1. A B C B. A B C D. B C D. A B C. Group 1. A B C. Group 0. All strings. Print m dot group 2. This will error out. B. How? Group 2 is B. Print m dot group 3. Tab. And for if I try to print, okay, for group in m dot groups, print G. 0 is A B C B. A B C B. A B C B. And A B C B. And zero m dot group 0 is whole string that is passed ABCD. Whole string that is passed for match. Print m dot group 1. So group 1 is A B C. This upper level outer parenthesis A B C. Outer level parenthesis ABC, and then print m dot group 1. This is inner level parenthesis, that is B. Print, there is no third, so let me print it ABC, ABC, ABC. Okay, second, sorry, B, correct. Now group can be passed multiple group members at a time, in which case it will return a tuple containing the corresponding values for those groups. So m dot groups, like this. Okay, we can pass this A as well. So print m dot groups, for example 0 1 2, so they can be group, not groups. A B C D, A B C B. Back references in a pattern allow you to specify that the contents of an earlier capturing group must also be found at the current location in the string. For example, \1 will succeed if the exact contents of group 1 can be found at the current position and fails otherwise. Remember that Python's string literals also use a backslash followed by a numbers to allow including arbitrary characters in a string. So be sure to use a row string when incorporating back references in RE. For example, the following RE detects doubled words in a string. So doubled words in the string. re.compile r \b \b. Okay. Word plus space 1. So this is the first group. Okay, repeated word. Paris in the string. Search, that's why it will return match objects. Print match. The okay. So back references like this are not often useful for just searching through a string. There are few text formats which repeat data in this way, but you will soon find out that they are very useful when performing string substitution, non-capturing and named groups. Elaborate REs may use many groups, both to capture substrings of interest and to group and structure the RE itself. In complex REs, it becomes difficult to keep track of the group numbers. There are two features which help with this problem. Both of them use a complex syntax for regular expression extensions, so we will look at that first. Perl 5 is well known for its powerful additions to the regular expression. For these new features, the Perl developers could not choose new single keystrokes meta characters or new special sequences beginning with backslash without making Perl's regular expressions confusing, different from standard REs. If they choose ampersand as a new meta character, for example, all expressions would be assuming that ampersand was a regular character and would not have escaped it by writing backslash ampersand or square bracket ampersand. The solution chosen by Perl developers was to use a question mark dot 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 as an extension syntax. Question mark immediately after a parenthesis was a syntax error because the question mark would have nothing to repeat. So this didn't introduce any compatibility problems. The characters immediately after the question mark indicate what extension is being used. So question mark is equal to foo is one thing, a positive look ahead assertion, and question mark colon foo is something else, a non-capturing group containing the sub-expression foo. Python supports several of Perl's extensions and adds an extension syntax to Perl's extension syntax. If the first character after the question mark is a p, you know that it is an extension that is specific to Python. Now that we have looked at the general extension syntax, we can return to the features that simplify working with groups in complex REs. Sometimes you will want to use a group to denote a part of a regular expression but are not interested in retrieving the group's content. You can make this fact explicit by using a non-capturing group question mark colon dot 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 where you can replace the dot 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 with any other regular expressions. M dot match groups. Print M dot groups, and if I print C comma groups A B C is the match. MRE dot match ABC. Print M dot groups question mark colon ABC question mark colon ABC plus ABC, correct, except for the fact that you can't retrieve the contents of what the group matched. A non-capturing group behaves exactly the same as a capturing group. You can put anything inside it, repeat it with a repetition meta character such as star, and nest it within other groups capturing or non-capturing. Question mark colon dot 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 is particularly useful when modifying an existing pattern, since you can add new groups without changing how all the other groups are numbered. It should be mentioned that there is no performance difference in searching between capturing and non-capturing groups. Neither form is any faster than the other. A more significant feature is named groups. Instead of referring to them by numbers, groups can be referenced by a name. The syntax for a named group is one of the Python specific extensions. Question mark p name dot dot dot. Name is obviously the name of the group. Named groups behave exactly like capturing groups and additionally associate a name with a group. The match object methods that deal with the capturing groups all accept either integers that refer to the group by number or strings that contain the desired group's name. Named groups are still given numbers, so you can retrieve information about a group in two ways. For example, m.group word, print m.group word, right? So r question mark p word is backslash b word plus backslash b. P dot search, okay, search one variance for lots of punctuation, lots, right? M dot group 1, you can also use this one, print m dot group 1, since because group 0 is the whole string by default. Group 0, group 2, that's an error. Additionally, you can retrieve named groups as dictionary with group dict. M is equal to re dot match group dict. Print m dot group dict. it will return groups, named groups as dict. Named groups are handy because they let you use easily numbered names instead of having to remember numbers. Here is an example RE from the IMAP lib module. It is obviously much easier to retrieve m.group zone m instead of having to remember to retrieve group 9. The syntax for back references in an expression such as dot 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 backslash 1 refers to the number of group. There is naturally a variant that uses the group name instead of a number. This is another Python extension. Uh, Question mark p is equal to name indicates that the contents of the group called name should again be matched at the current point. The regular expression for finding doubled word is this one, can also be written as this one. So if I do this one, p dot search group, print. So word is word space or word, p is equal to word, the other. Look ahead assertions. Another zero width assertion is the look ahead assertion. Look ahead assertions are available in both positive and negative form and look like this: question mark equal to dot dot dot, positive look ahead assertion. This succeeds if the contained regular expression represented here by dot 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 successfully matches at the current location and fails otherwise. But once the contained expression has been tried, the matching engine doesn't advance at all. The rest of the pattern is tried right where the assertion started. Question mark colon exclamation sign dot dot dot, negative look ahead assertion. This is the opposite of the positive assertion. It succeeds if the contained expression doesn't match at the current position in the string. To make this concrete, let's look at a case where look ahead is useful. Consider a simple pattern to match a file name and split it apart into a base name and an extension separated by a dot. For example, news.rc. News is the base name and rc is the file name's extension. The pattern to match this is quite simple. Dot star in square bracket dot star dollar. Notice that the dot needs to be treated especially because it's a meta character, so it's inside a character class to only match that specific character. Also notice the trailing dollar. This is added to ensure that all the rest of the string must be included in the extension. This regular expression matches foo.bar and autoexe.bat and sendemail.cf and printers.conf. Now consider complicating the problem a bit. What if you want to match file names where the extension is not BAT? Question mark. Some incorrect attempts. Dot star dot start of B dot star. The first attempt above tries to exclude bat by requiring that the first character of the extension is not B. This is wrong because the pattern also doesn't match for foo.bar. Dot star dot then B dot dot or dot A dot T dot. The expression gets messier when you try to patch up the first solution by requiring one of the following cases to match. The first character of the extension is not B, the second character is not A, or the third character is not T. This accepts foo.bar and rejects autoexe.bat, but it requires a 3-letter extension and won't accept a file name with a 2-letter extension such as sendmail.cf. We will complicate the pattern again in an effort to fix it. Dot star dot B dot question mark dot star dot caret A question mark or dot question mark caret T question mark T. In the third attempt, the second and third letters are all made optional in order to allowing matching extensions shorter than 3 characters, such as sendmail.ca. The pattern is getting really complicated now, which makes it hard to read and understand. Worse, if the problem changes and you do want to exclude both BAT and EXE as extension, the pattern would get even more complicated and confusing. A negative look ahead cuts through all this confusion. Dot star dot um, question mark exclamation sign bat end of end dollar uh, caret dot star. The negative look ahead means if the expression bat doesn't match at this point, try the rest of the pattern. If bat and dollar does match, the whole pattern will fail. The trailing dollar required to ensure that something like sample.batch, where the extension only start with bat, will be for allow. The caret dot star, which makes sure that the pattern works when there are multiple dots in the file name. Excluding another file name extension is now easy. Simply add it as an alternative inside the assertion. The following pattern excludes file names that end in any other bat or exe. Dot star dot question mark exclamation bat dollar or exe dollar end of parenthesis start of square bracket caret dot star dollar. Modifying strings. Up to this point, we have simply performed searches against a static string. Regular expressions are also commonly used to modify strings in various ways using the following pattern. Method attribute purpose split sub split. Split the string into a list, splitting it wherever the RE matches. Sub, find all substrings where the RE matches and replace them with a different string. Sub n does the same thing as sub but returns the new string and the number of replacement. Splitting strings. The the split method of a pattern splits a string apart where the RE matches, returning a list of the pieces. It is similar to split method of strings but provides much more generality in the delimiters that you can split by. String split only supports splitting by byte spaces or by a fixed string as you would expect. There is a module level re.split function too. Dot split string max split is equal to 0. Split string by the matches of the regular expression if capturing parentheses are used in RE. Then their contents will also be returned as part of the resulting list. If max split is non-zero, at most max split splits are performed. You can limit the number of splits made by passing a value for max split. When max split is non-zero, at most max splits will be made and the remainder of the string is returned as the final element of the list. In the following example, the delimiter is any sequence of alphanumeric characters. P re.compile w plus p split this. Result. Print result. So re.compile are capital W, so ignore words. So means run. This is a test short and sweet of split. What will be the output of this split? W p dot split. This is the test for 3, only 3. So only three splits, one, two, three, and then rest of this two. Sometimes you are not only interested in what the text between delimiters is, but also need to know what the delimiter was. If capturing parentheses are used in RE, then their values are also written as part of the list. Compare the following calls. P dot display result is equal to P is equal to RE dot compile this one. P2 is equal to RE dot compile this one. Print result. Okay, run it. This is a test. This is a test. W plus P dot split. Okay. Dot is ignored. This is a test. And P2 dot split. This is a test. What is the difference? Result is equal to P2 dot dash and run is. Okay, P2 what is the difference, man? What is the difference here? I do not see any difference. Why there are two vessels for the same thing? This is sand, this is sand, this is sand. No, no, no. Here we have used groups and here we have used string literal. The module level function re.split adds the re to be used as the first argument but is otherwise the same. So this one result import re module result is equal to this print result. Words and re dot split w plus words. This is group using groups, the same thing using groups. Print result. This will return rest of the cases. Search and replace. Another common task is to find all the matches for a pattern and replace them with a different string. The sub method takes a replacement value which can be either a string or a function and the string to be processed. Dot sub replacement string count is equal to 0 returns the string obtained by replacing the leftmost non-overlapping occurrences of the re in string by replacement. If the pattern is not found, string is returned unchanged. The optional argument count is the maximum number of pattern occurrences to be replaced. Count must be a non-negative integer. The default value of 0 means to replace all occurrences. Here is the simple example of using sub method. It replaces color names with the word color. P recompile shoes. Result is equal to P dot substitute print result. So here compile blue or white or red. Okay, and P dot substitute color where these are matches. So here color socks and color shoes. P dot substitute count is equal to 1. Only one substitution will be done, performed. So result is equal to this. Here only one substitution will be performed. So the result would be color socks and red shoes. The sub and method does the same work but return a two tuple containing new string value and the number of replacements that were performed. So let's do this again. So sub n, run it. So it will return two substitutions, one substitution. Empty matches are replaced only when they are not adjacent to a previous empty match. P array.compile p sub hyphen p sub hyphen result is equal to, so x star and sub x star. So x, so here a b hyphen a hyphen b hyphen 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 this. Why? Zero or more. Oh, that's why. If we say one or more, then the result will be what I was expecting. AB hyphen D. Yep. Because of this, it produces that result. Correct. If replacement is a string, any backslash escapes in it are processed. That is, backslash n is converted to a single new line character, backslash r is converted to a carry as written, and so forth. Unknown escapes such as backslash ampersand are left alone. Back references such as backslash 6 are replaced with the substring matched by the corresponding group in the RE. This lets you incorporate portions of the original text in the resulting replacement string. This example matches the word section followed by a string enclosed in parentheses and changes the section to subsection. Result is equal to this. So section, parentheses, space, ignore this caret sign, star, and parentheses and parentheses. P subsection /1. There is also a syntax for referring to named groups as defined by the question mark p name syntax. A backslash g name will use the substring matched by the group named name, and g number uses the corresponding group number. Backslash g2 is therefore equivalent to backslash 2, but is not ambiguous in a replacement string such as backslash g20. 20 would be interpreted as a reference to group 20, not a reference to group 2 followed by a literal 0. The following substitutions are all equivalent but use all three variations of the replacement string. G1, Gname. Replacement can also be a function which gives you even more control. If replacement is a function, the function is called for every non-overlapping occurrences of pattern. On each call, the function is passed a match object argument for the match and can use this information to compute the desired replacement string and return it. In the following example, the replacement function translates decimals into hexadecimal. Def exa hex replacement match. Return the hex string for a decimal number. Value is equal to integer match dot group. Return hex value. P is equal to re dot compile. P dot sub hex replacement call 65490 for printing, 49152 for user code. Let's run it. Result is equal to this. Print result. Run it. Call for this for printing and this for okay. When using the module level re.sub function, the pattern is passed as the first argument. The pattern may be provided as an object or as a string. If you need to specify regular expression flags, you must either use a pattern object as the first parameter or use embedded modifier in the pattern string. Example sub question mark I e plus x bbb returns xx. Common problems. Regular expressions are powerful tool for some application, but in some ways their behavior is not intuitive and it at times they don't behave the way you may expect them to. This section will point out some of the most common pitfalls. Use string methods. Sometimes using the RE module is a mistake. If you are matching a fixed string or a single character class and you are not using the RE features such as the ignore case flag, then the full power of regular expressions may not be required. Strings have special methods, several methods for performing operations with fixed strings, and they are usually much faster because the implementation is a single small C loop that has been optimized for the purpose instead of large more generalized regular expression engine. One example might be replacing a single fixed string with another one. For example, you might replace word with deed. Re.sub seems like the function to use for, but consider the replace method. Note that replace will also replace word inside words, turning swordfish into as did fish. But the native RE word would have done that too. To avoid performing the substitution on parts of the words, the pattern would have to be backslash b word backslash b in order to require that word have a word boundary on either side. This takes the job beyond replace ability. Another common task is deleting every occurrences of a single character from a string or replacing it with another single character. You might do this with something like re.sub backslash n uh, space s, but translate is capable of doing both tasks and will be faster than any regular expression operation can be. In short, before turning to the RE module, consider whether your problem can be solved with a faster and simpler string method. Match versus search. The match function only checks if the RE matches at the beginning of the string, while search will scan forward through the string for the match. It's important to keep this distinction in mind. Remember, match will only report a successful match which will start at 0. If the match would not start at 0, match will not report it. Print re.match super superstition span 05. Print re.match super insuperable. On the other hand, search will scan forward through the string, reporting the first match it finds. Sometimes you will be tempted to keep using re.match and just add dot star to the front of your RE. Resist this temptation and use re.search instead. The regular expression compiler does some analysis of REs in order to speed up the process of looking for a match. One such analysis figures out what the first character of a match must be. For example, a pattern starting with crow must match the starting with a C. The analysis lets the engine quickly scan through the string looking for the starting character only trying the full match if C is found. Adding dot star defeats this optimization, requiring scanning to the end of the string and then backtracking to find a match for the rest of the RE. Use RE dot search instead. Greedy versus non-greedy. When repeating a regular expression as in a star, the resulting action is to consume as much of the pattern as possible. This fact often bites you, and when you are trying to match a pair of balanced delimiter such as angle brackets surrounding an HTML, the naive pattern for matching a single HTML tag doesn't work because of the greedy nature of dot star. S is equal to HTML head title length S is equal to this print re dot match less than dot star greater than S dot span 0 to 32 print re dot match group like this. The RE matches the less than in HTML and the dot star consumes the rest of the string. There is still more left in the RE, though the greater than can't match at the end of the string, so the regular expression engine has to backtrack character by character until it finds a match for the greater than. The final match extends from the less than in HTML to the greater than in the title, which is not what you want. In this case, the solution is to use the non-greedy quantifiers star question mark plus question mark or mn question mark, which matches the little text as possible. In the above example, the greater than is tried immediately after the first less than matches, and when it fails, the engine advances a character at a time, retrying the greater than at every step. This process produces just the right result. Print re dot match less than dot star question mark greater than as group HTML. Note that parsing HTML or XML with regular expressions is painful. Quick and dirty patterns will handle common cases, but the HTML and XML have special cases that will break the obvious regular expression. By the time you have written a regular expression that handles all of the possible cases, the pattern will be very complicated. Use an HTML or XML parser module for such tasks using re.verbose. By now, you have probably noticed that regular expressions are a very compact notation, but they are not terribly readable. Arrays of moderate complexity can become lengthy collections of backslashes, parentheses, and meta characters, making them difficult to read and understand. For such arrays, specifying the re.verbose flag when compiling the regular expression can be helpful because it allows you to format the regular expression more quickly. The re.verbose flag has several effects. White spaces in the regular expression that is not inside a character class is ignored. This means that an expression such as dog or dog cat is equivalent to the less readable dog or cat, but AB will still match the characters A, B, and or a space. In addition, you can also put comments inside a RE. Comments extend from a hash character to the next new line. When used with triple quoted string, this enables REs to be formatted more neatly, like this. This is a far more readable than this. Feedback. Regular expressions are a complicated topic. Did this document help you understand them? Were there parts that were unclear or problems you encountered that were not covered here? If so, please send suggestions for improvements to the author. The most complete book on regular expressions is almost certainly Jeffrey Friedel's Mastering Regular Expressions, published by O'Reilly. Unfortunately, it exclusively concentrates on Perl and Java's flavors of regular expression and doesn't contain any Python material at all, so it won't be useful as a reference for programming in Python. The first edition covered Python's now removed regex module, which won't help you much. Consider checking it out from your library. Thank you.